Shark! Shark! Nope, not in the water. In my shop. Yep, I bought a CNC, folks. A Shark HD5 extended bed from Nextwave Automation. Did a full assembly video. You want to see how it went? Grab a seat and some popcorn and hang on. Alright, don't judge me. No, I didn't build the stand for the Shark. But what I did do was buy the Kreg Universal Workbench. Thing is solid as a rock and very functional and very versatile. I got the mobile base for it, or the casters for it, so I can move it around the shop as needed. Here I'm using some jigs to sort of keep everything square as I'm assembling it. I know I should have built it, but we're past that now. So this thing takes a full 36 by 64 footprint. So I needed to make sure that this thing was solid. The stand that I got was a 28 by 64. Most of that's just slightly hanging over is the little bit from the stepper motor, which isn't going to be a problem. Alright, now that the stand's assembled, time to muscle up some particle board. Yep, I decided to use particle board as a top. A couple of reasons. One, when it's glued together, it's pretty strong. Two, it's really cheap, so it fit my budget. So just going to get this thing chopped off the length, then I'll come back and rip it to width. Quite the chore in a little shop, especially when you got boxes all in your way over there. But I make do and manage to make it work. And so now I'm putting the top back on there and get everything as nice and tidy and even. And I will say, you definitely want full support of the bottom for the Shark. The way that's designed, you want to make sure you get a nice full bottom. It can't be open, so you need that flat top. So anyway, get that thing together. I put some Titebond 3 between the two layers, add a little bit of strength, and then of course I'm coming back behind that and throwing in some 1 1/4 inch screws. My daughter shows up. I told her come back in an hour, help me lift the machine up. I think she's either really early or really late. She's a teenager, so I'm going to lean towards I'm really late. Yeah, it was my fault. I decided to lay out router pad underneath between the machine and the top. A couple reasons. One, I'm hoping that it'll help dissipate some of the vibration between the machine and the stand, and I'm hoping it'll also help dissipate some of the noise from the machine itself. So I had to remove my little window fan shelf thing, and now I'm just making sure that the top is fully fastened to the stand itself. Quite a lot of work to get done, so I'm putting out all the parts and pieces out on the top just so I can get a good look at it and make sure I've got everything I need before I move forward. Carefully cutting away the plastic that's wrapping up the gantry. I certainly don't want to nick any wires while I'm unwrapping that. So everything's laid out on the table so I can see what all I have. Of course, I got the controller way back in the back there. Several cables. Some go from the controller to the wall, some from the controller to the pendant. So got a variety of things there. And of course, there's the color pendant. Some hold downs, some wire hose, some track that's going to be handy later, and some hardware. And then of course that gantry. Yeah, baby. Alright, so let's get started here. First thing we want to do is install that gantry. Get a friend to help just to hold that thing up if you can, or just use a scrap block to hold it up like I did. Us rednecks get a little ingenious from time to time. There's a close-up of installing the 6 bolts that go in each side of the gantry that holds the gantry to the gantry support. A bracket coming out each side. Don't over tighten, but you want to get it snug enough that it's not going to go anywhere. Look good. This part took a little time, very time consuming, not hard, just time consuming. You got to pop the tabs on all the little caps on the track. This is what the wire is going to be going into so it keeps it out of the way so it doesn't get tangled up. It came with 2 rectangular T-track nuts that go into the track to kind of hold it into the front. You'll see later how they could have used a couple more. So then I feed the wire down the right way, down the side, through that wire track to kind of get everything where it needs to be. Again, a little time consuming, but take the time now to get it done right, and you won't have problems down the line. finally get it all assembled, so I'm putting it in that wire protector. I will warn you about this. We'll talk about that magnet that holds that up later. Now it's time for the router. I chose the Bosch 1617. It's a good powerhouse router. It's going to work well. Bosch is a good quality brand. So let's get all the wires hooked up to the control box now. All the wires are labeled on their harnesses X, Y, and Z, so it's pretty easy to match that up. Don't mix them up. Get them right. So I took some initial measurements from the router motor using a bit down to the table. The table was slightly off from one end and side to the other, but that's typical of an aluminum top, and that's the other reason why we're going to put on a spoil board. Okay, I wanted to give you a quick rundown of how I'm going to do my spoil board. I'm not going to do a total slab like a lot of people do. I just didn't want to do that. I don't like that setup. I prefer having the little strips like this. One reason is it gives me still full functionality of my T-track, which is pretty important. It's the most stable thing on the machine. So I wanted to have access to this. So what I did was I created a spacing between each one, and on each spoil board strip I'm going to have a T-nut embedded on the bottom and recessed like this. So that's going to allow me to have functionality here. The nice thing about that is it has a really wide shoulder, so I get plenty of support on the bottom side as things are pulling up. And unlike a threaded insert, it's not going to pull through. So that's going to be much stronger than the threaded insert and much more stable to the part. Then inside, I've also got this rectangular T-track nut. So what that's going to do is going to fall into that track and work extremely well for holding it down. And again, I've offset these little holes, so I'm going to get surface pressure evenly across the whole surface of the piece. And you can see the screw that's going to go into that is a 1/4 by a 1/2 inch long with a very flat washer head screw. That's going to do real well for that. How that works: slide that T nut in, or that T-bolt in, and then as you tension this down, it's going to lock it in place. There's my gap. The same thing will happen here, here, and here, and I've done that across the whole surface. So all in all, once this is done, having that T-nut in there will allow me to have a lot of stability on top for making jigs, fixtures, and fences. I'll still have the full functionality of the T-slot for in the actual bed. So this is going to be a good setup for me. It's going to work really well, and so we'll continue on with the build. So hold tight and keep watching. So now I went ahead and took some time because I was having some problems with the assembly. The router wouldn't start when I turned the machine on. Turns out it was a simple wire that had come loose in the solid state relay, a 2-minute fix. So in the meantime, while I was thinking and trying to figure out my problem, I thought I'd go ahead and knock out the spoil board manually. Yep, all these boards were hand drilled on my drill press. Thankfully, I had just built this drill press with this nice micro jig, micro fit dovetail system. Man, what a time saver. The thing rocked it. So anyway, get the rest of those things drilled, bored out, and a lot of little holes to put in there. But it'll be worth it once it's all said and done. So got all the holes bored. Now it's time to put all those T-nuts in. Man, what a chore. But I think I bought the store out when I did that. But anyway, I've got those T-nuts on the bottom. They're probably, I think it's like every 8 or 9 inches, so it's going to have decent spacing. A lot of capability and functionality for making my own jigs and fixtures and hold downs and other things. So anyway, working like a chore, and I'll just let you watch and listen to this awesome music. Now for the fun task of putting all those slats into the T-track. I thought about doing them all on the workbench and then bringing them over and sliding them in. Might have been a faster way than the way I did it. Putting them on one by one and then sliding them in a little at a time. It did take some time. So, next time, I'll know. And now what I did for my math here was I figured out, using the router, I went all the way around the perimeter to kind of see what my cutting perimeters were. Then I added about a 1/2 inch all the way around, because a 1/2 inch essentially is going to give me more than enough with a spoil bore bit to clean those off straight. So that's kind of what I did. It ended up with a pretty nice little work surface. I put a board on the end to get all of them lined up where they needed to be. One, so I know where they were, but two, that allows me to line them up all straight and even like, you know. I'm not totally redneck. I do want to have some semblance of quality control there. So going through there by hand tightening all those little screws. Took some time, but well worth it. I know I could have used a battery operated drill, but sometimes just hand tightening is all you need. And it works.
Okay, it's all assembled. The wire track goes from front to the back. Well, it makes a loop there, and the problem that I'm foreseeing being a concern is they've got this little magnet right in there that's supposed to hold this track up. Well, at certain parts it is just too heavy, especially when it's moving more towards the front of the machine. So I don't like it. So my temporary solution is to put a block in there like that, and it raises it up so at least it's supported. And this is far enough in that it's not going to come into contact with that wire, so I'm good to go there. They did supply, and I'm trying to see here, if you look down in there, you can see some little T-nuts right there. There's one there, and then one down here. That does a good job of holding the track, but there's only 2 of them, and that's a long span. So my solution was that block, so we'll see how well that works.
I threw a V-bit in the router and manually went around the perimeter of my spoil board. Just wanted to see what that looked like. Gave me an idea of what the border was going to be. Now I'm setting up the spoil board bit, setting up 0 on the controller using the touch plate. That thing is handy. And I'm using the Amana RC22-55. I'm going to tell you, what a beast of a spoil board bit that is. If you got a big spoil board like I do, that makes extremely short work of it. And I wasn't going to take off at just a couple thousandths. I think I figured it for 10 thousandths of removal. Not much. I don't want to waste everything right out of the gate. So just looking at the control panel, seeing some of the functions in there, I did cut the speed down to about 80%, just until I make sure everything's running smooth. What a clean line. I will tell you, if you do this, you best have your dust boot connected. You can see the fog of dust just being thrown by that bit. I even had to hook the dust collection and manually remove it. Then I notice a problem. See that line? That showed me something that I didn't like. So, time to do some evaluation again.
Oh no, you might be saying, where's everything at? Well, the router's hiding over there. The bracket that holds the router is over there. And so, yeah, what happened was when I got the router finally running, the solid state relay wire was loose. You can see that when I ran my toolpath to surface my spoil board, I ran it along the y-axis front to back. Well, you can see it created these little divots. Well, what that told me was the router was sitting slightly angled at this direction, okay, instead of perfectly perpendicular. So it was slightly canted, and that created these grooves. Now that doesn't seem like much to many, but that will throw you off big time when you go to try to make precision cuts. So I thought that I could use the 4 bolts that hold the router mounting bracket onto the main bracket, but there wasn't enough slop in it, which is a good thing. That means they had pretty tight tolerances. However, that meant that I had to take it off to access these 8 screws. And you can see here when I did my initial test, I had some little score lines I scratched with an awl to try to get a reference point. But again, not enough movement. So I took these 8 screws loose and squared everything up. I knew my table was perpendicular to the gantry and to the router, but as far as being flat, it wasn't. So I put this reference on here to give me a flat reference across the surface. I referenced it from my square, and you can see that's pretty dead on. I also referenced it using my little machinist's square, which I had it a little lower a moment ago, and that was good. So I confirmed it by finally measuring it with this digital square. I knew where my 0 was. I got everything zeroed out, leaned it up against both sides of the block to confirm, and we are square.
I used my angle cube to confirm everything. I measured it side to side and front to back. Perfect 0. I am ready to roll. So I did my spoil board again with the dust boot on this time. Then I noticed an issue. The little brushes on the dust boot get sucked into the hole, which means I'm not getting dust pulled away from the machine. I'll fix that later. Here's the final assembly. Perfect. No lines. Everything is flat and looking good. So I cranked up the Aspire program and made me a little plaque. I needed some way of converting the numbers on the router to what actual RPM rating was going to be. And that worked out well. I absolutely love that Vectric Aspire. And here's the router working for the first time. And you'll notice I did build me a little fence there too. Thank goodness for all those holes and T-nuts and slots that I made in the table and spoil board. Worked out well, I think. This gives me a really good alignment location for all the projects that I can put in there. And that router is working like a champ. And I'm using the 60-degree V-bit from Amana. This is probably one of my favorite bits that I use for almost all my V-carve needs. Very clean and crisp. That Spectra coating, man, it just gets the job done. And you'll notice I am using my shop vac to manually pull the chips away, since my dust boot, well, you know what happened there. You'll have to check out my other video for my upgrade to that shop dust boot. Decided to go with the Kent. You want to see more about that? You'll have to check out that other video here. So there you go. I did decide I wanted a full length fence, so I did a longer fence on the y-axis and the full width on the x. I didn't get the footage of that, but there it is. But I did decide I wanted to go ahead and square that up, so I manually jogged the router with a 1/4 inch Amana down cut bit, and I'm just traveling just about 1/8 of an inch off the edge. When I get to the corner, you will see that I make a little notch there. That's going to help keep debris from getting caught in that corner, and I've got a plan for that, which I'll show you later. But anyway, so now the Y and the X is perfectly square to the table, and all is well.
Alright, well there you go. The final assembly and first run of the Shark HD5 Extended from Nextwave Automation. I had some bumps in the road getting here, but you know, those are good things to learn anyway. So learning how to dial in the router motor and tweak the bracket and do some of the other things that I had to do, that worked out really well. So The first run turned out good. I look forward to many more on this machine. I do have a full 25 by 50 cutting capacity, so that's going to be good. And we're done. You know, I do, at least with the main assembly, I plan on coming back since I did get the Kreg stand for this. I do plan on filling that in with some cabinetry, drawers, doors, shelving. Just got to really use the machine a little bit and figure out how I want to do that and what exactly I want, because now I can fully customize that to my liking and go from there. But this has worked out really well. Look forward to using it. That powerful Bosch 1617 2¼ horse router is going to get it done. And like the color pendant, I've got the hold down, I got the spoil board. So far I've got it almost exactly the way I want it. So stick with me and watch this journey as we modify this and upgrade this and add a few more things to it and really make it my own. So that's it for now. Chris with Christcross Crafts introducing you to the new member of the family, the Shark HD5 Extended from Nextwave Automation. So lots of CNC fun coming ahead. Stay tuned, folks. I got the controller, the HDMI cable, and it's not the right cable, so we'll voice that over. Pendant, a couple of clamps, a little piece of hose, the track, hardware to mount the gantry,